Hi. In A-level geology, there are a number of geological structures that can be set in the black and white problem maps that extend our understanding of structures beyond what we did for AS level. This is an example of such a structure. Here again we've got a circular geological structure shown from a Google Earth image. Yet this one doesn't have an igneous rock at its core or its cores. This particular structure is what we call an upheaval dome. This one is from Utah and is the result of a salt dome underneath the surface pushing the rocks up. What we see as a result is the formation of what we call a dome. This is a fold where the dip of the rocks goes in all directions away from a central point. So rather than being perhaps a definitive axis of a fold, we see dips radiating out or even inwards in a radial pattern. Now these features aren't exclusively in exotic foreign places. We have examples here in Wales. This is an area we call the Harleq Dome. Up in north West Wales, we have these structure of rocks. If we look, we can see we've got this circular pattern. There's offset by a few faults, but we can see overall there's a circular pattern. If we look at the age of the rocks here, we can see the oldest rock, the Dolwen Formation there, right in the middle of this structure, and the youngest rocks, the green ones of the Mawddach group, around its edge. So this feature is anticlinal in form. Oldest rocks in the middle, youngest at the edge. There is perhaps an elongation, roughly north-south, but we're seeing dips of these rocks then that will go from oldest to youngest in all directions coming out from that central core of old rock. So this structure is a dome. It's an anticlinal domed structure. Now it's not the only example we have here in Wales. If we come even closer to home, we see a map here of the South Wales coalfield. The oldest rocks here, the Carboniferous Millstone Grit and the Maros group, shown in green, around the edge of this this oval-shaped outcrop pattern, getting progressively younger into the middle with the yellow Llantwit beds there. This shows us that this is a basin. It's a synclinal form, youngest rocks in the middle, oldest rocks at the edge. But the dips of these go in towards the middle. Now there is, again, an elongation here. This one roughly east-west, as it's from the Variscan orogeny. But because we have dips going into the middle here, we describe this as a basin. Now Map E has some examples of these. Drawing these onto a cross-section is relatively straightforward. We don't, to be honest, need to worry a great deal about this structure on one cross-section. However, if we're looking at this in terms of drawing axial planes or trying to describe the structure of an area, then we do need to consider it. Look, for example, at the pattern of dip arrows that we can see going around the oval-shaped structure in the northeast of this map. So, as ever when we start one of these maps, See if you can highlight and label up the fold axes, the faults, any unconformities or intrusions that are formed. And then have a go at drawing the cross-section. So, as we see the sunset over Harleq Castle, once you've put together your cross-section and answered the rest of the questions, check out the answers. See if you can work out how we've put together that sequence of geology from the evidence on the map.